Okay, these are the notes on 6.4, the elimination method. So we're going to start out with something we saw on Kirk's notes, and that was the solutions to systems remain solutions if properties of equality are used to rewrite either of the equations. So we're looking right here. The equations in the system are added or subtracted together. So in other words, we're allowed to add the equations in a system together. And number 3 says any rewrite of the equations is added or subtracted together. So you'll notice that in his video, there were only 2, and I took his 2 and kind of broke it up a little more. So this will make more sense, I think, after we look at examples, and I'll refer back to them, but it's not like this is something you need to memorize. I do want you to write down everything that you see in this video. Okay, so here we go. The first definition, the only definition I think that's important here, is that the word eliminate means to combine two additive inverses together. And an example of that would be negative 3x and positive 3x added together equals 0. So the act of putting two opposites together, like negative 3 and positive 3, negative 3x and positive 3x, they equal 0. And the act of doing that is called eliminating. So we're going to refer to that. Okay, so let's look at the steps. These are the steps that I'm going to refer to. I have my own ways of referring to them, but this is just a very clear way of writing them down. So step 1, line up like terms for all equations, meaning make sure your x terms are lined up over other x terms, y terms are lined up over other y terms, and equal signs are lined up on top of other equal signs. And constant numbers without variables, are lined up with other constant terms or constant numbers. Number 2, look for additive inverse coefficients. So coefficient refers to the negative 3 and the positive 3 up here in this example. But notice how it's also, they're both x's. They're both also x's. So if you can't find some, then we'll make some by multiplying one or both of the equations, and that will involve distributing. Okay. Number 3, eliminate one variable and solve for the other variable. Number 4, use your answer from step 3 to find the other variable's value by substituting what you found into one of the system's equations. And number 5, write your answers from steps 3 and 4 as an ordered pair. And this still is when applicable. So when, maybe we can write just when possible. Because sometimes we're looking for the number of shirts, t-shirts, and button-up shirts that somebody bought. And that's not an X and a Y, so they couldn't be written as an ordered pair. And I think some of us talked about that yesterday, too, in our Google Meet. All right, so pause the video if you need to keep writing. I have to switch slides. Okay, here's example number 1. So these examples are going to start out easy, and they're going to build up to the more challenging type of problems. So in example number 1, we see it says solve the system, and it says add to eliminate. It also says there's no multiplying necessary. So what do I mean by that? I mean, we're going to add these two equations together. We're going to just total them up. So remember, totaling, this is the total line. Okay, it's already drawn there for us. All right, and we are going to total them. So I personally don't like to say add, because what if adding is more like subtracting? What if you're combining a negative number with a positive number, and to you it feels more like subtracting? So I like to just say total or combine. Okay, but either way, we still use the same symbol. The plus sign still means combine terms according to their signs. So, notice how my x terms are lined up with my x terms, my y terms are lined up with my y terms, equals are lined up with equals, and constants are lined up with constants. Okay? Very important with the elimination method. So 2x plus 3x makes 5x. Oops. Negative y and positive y make 0. So I could write a 0 here, but that's going to look weird next to the 5x. We're going to leave that out. We're actually going to come up here and just cross out the negative y and the positive y because they eliminate, okay? We need to write our equal sign, very important. And then we have 2 and 13. So 2 and 13 total combine to 15. And so thinking ahead, we can see x is going to equal 3, but we should show how we get our answer. So we divide by 5, and we get x equals 3. So that's part of our answer. So we can jump all the way over to the right here, and thinking about x comma y format, we know our x now, so we can kind of write that down just to put it away so we can think about y. So now, thinking back to our other steps, step 4 says use what you found to substitute to find the variable you don't know. So now I'm going to substitute. And again, like the other day, I said pick the easiest equation. Sometimes the easiest one is the top equation. It depends. In this case, I'm going to pick the bottom equation. It doesn't matter. But it's up to you. 3x plus y equals 13. Okay? Now I'm going to substitute. 3 times 3 plus y equals 13. Keep going. 9 plus y equals 13. So we know now that y has got to be 4, but we keep going to prove it. So we subtract 9 from both sides, and we get y equals 4. Now we have another part of our answer, and we need to bring that over to our ordered pair. So this problem is done, actually, and it's done because I have my ordered pair. Now, if we look back at the directions, it said solve the system. It also said no multiplying necessary. Because when I look at this problem, okay, I notice that it says it has a negative y and a positive y. And I like to always start out these problems by saying, do I have opposites or do I need to make opposites? In this case, in question 1, I already had opposites. And I know you guys are stronger, so I can say instead of the word opposites, I could say additive inverses. So I could say to you, do we have additive inverses? Or do we need to make additive inverses? And the answer here is I already have additive inverses. So I'm going to write that up here. I already have additive inverses. And that's the negative y and the positive y. And that's why they eliminate. Okay? All right, let's move on to the next question. Number 2. This one says solve changing the signs to eliminate. So I'm going to start out the same way. Okay? Do we have additive inverses or do we need to make them? And in this case, hopefully the directions gave it away. We are going to need to change the signs of one of the equations in order to have additive inverses, which means in order to eliminate. So I'm going to write here, we need to make additive inverses. So let's take a look at this. Would it be easy to make the x column into additive inverses? Well, I could. I could multiply the top equation by what number? Negative 3, hopefully is what you thought. Okay, and that would give me negative 3x and positive 3x. That is a possibility. Or let's take a look at the y column. I could look at the y column and notice that the y's are identical, and all I would need to do is multiply one of these equations by a negative 1, and that would turn my y column into negative y, and the other y could just stay positive y. So you can choose whichever one you want, okay? I'm going to show you just multiplying by -1. So the way I do this is I like to show a yield arrow, which you see in science a lot. It just means will produce or will cause. It doesn't mean equals exactly. It's just saying this will make the next thing. So I'm going to show distributing on the top equation. It could be the bottom equation too. In this case, it doesn't matter. I'm going to show distributing of a -1. And the reason I'm multiplying by -1 is because I want to make this positive y into a negative y. Okay? All right. So -1 times x is -1x. -1 times positive y is -1y. -1 times positive 8 is -8. Okay? So that one is now, that one's been multiplied or manipulated to, manipulate is the wrong word, but just multiplied, distributed to make it look different. It's still the same equation, okay? This equation and this equation are the same equation. They are equal, but we've changed the look of them through multiplying. Remember, if you multiply the whole side, meaning the whole left side and the whole right side of an equation, you haven't changed the value of the equation. You've only I lost my train of thought. You've only changed the look of the equation. Okay? All right. So, let's keep going. So we have -3x down below, -3x plus y equals 10. So I left the bottom equation black because it's not going to change. Now, ask yourself, do I have additive inverses? I do. The y's are additive inverses. I'm ready to total. So I'm going to go -1x plus 3x is 2x. -1y plus 1y is eliminated. Equal sign comes down. -8 and +10 make +2. Thinking ahead, I need to divide both sides by 2, but I know my answer is going to be 1. So I divide both sides by 2 and I get x equals 1. That's part of my answer. Thinking ahead, I've got an x comma y as a goal, and I'm trying to write 1 into that ordered pair so I can be ready to finish up. All right, now I'm going to substitute what I found. Pick either equation. Which equation looks easier to you? I picked the top one. You can pick either one. X plus y equals 8. Substitute. 1 plus y equals 8. Subtract the 1 from both sides. We get y equals 7. There's the other part of our answer. Put it in your ordered pair, box out your answer. Take a minute, pause the video, write down what you need to write down.